Alright, so this is sort of my submission for the code comment thing. I wanted to go through all of my code instead of just 30 lines, and I find it a lot easier to go through it this way than to write. Yes, let's start. So we're first including a couple of libraries. So we have a PID library, an encoder library, and a task scheduling library, as well as all this other stuff that I wrote. So we're initializing the bot class. You can see here we have all these pins. So if we go to the bot class here, so you can see we have the the forward and back for left motor, forward and back for right motor, the two line sensors, the encoders for the left one, and the encoders for the right one. So we're taking all of these, and we're just passing them into this the motor structs with these. So if we go over to the motor structs, you can see we have our two motor pins, our two encoder pins. So first we initialize an encoder using the two encoder pins. We initialize some PID stuff, and then this is just storing the pins into thing. It's kind of not needed anymore. And then we're setting the pin mode of each of the two motor pins. So then if we go back to bot, okay, so we've done that, we've initialized it, we'll go back here. Okay, so then we're setting up the reckoner. So if you go over to our reckoner class, you can see that we have the wheel diameter, the wheel base length, and the encoder ticks per revolution. So I couldn't quite figure out how to use pointers to store this directly, so I just sort of have an underscore variable here, and then I'm just like setting it like this, which there's probably a better way to do this. I don't know how to do it though. We have some stuff that I'm using. This is just radians to degrees, and this is like the threshold, which for the line sensors. So we have our X target coordinate, our Y target coordinate, our angle target, and angle factor. I'll explain the angle factor later, but yeah, this is our coordinate for our sort of navigation system. This is our speed that we want to go on. These are our three main PID loops. So currently I've only implemented angle hold and velocity hold because this one I'm having some issues with. So angle hold, what it does is that this is activated when the robot is in the turning sequence, and it tries to hold a specific angle, drive to a specific angle. Velocity hold is used to maintain the speed target, so for like forwards and backwards not turning. So something to note is that velocity hold and angle hold always run at the same time. So if the robot is driving forwards with, like, let's say 10 speed, if it turns slightly, it will turn back using the angle hold PID to try and maintain its angle. So here we have our target coordinates for X and Y. You can see I have 3 target coordinates in here. The system that handles this is very jank. I need to improve it. And then this is just a counter to keep track of which coordinate we're on. This is the tolerance for the coordinates. The coordinates are all in millimeters, so we have to be within plus or minus 50 millimeters for it to think it's in the right position, and you need to be plus or minus 10 degrees for it to be okay with the turning angle. So now, this is some task stuff. So if you remember, I have a task scheduler library in here, so I'll explain what this does. So these are just some method prototypes. So we have an encoder task, we have a reckoning task, a PID task, and a bot state task. So let's run through this. So we'll first sort of talk about how fast they're running, and then we'll see what each one does. So the encoder task runs every 1 millisecond. The reckoning task runs every 5 milliseconds. The PID task runs every 20 milliseconds. And the bot state task runs every 200 milliseconds. Something to note is that these have a priority. So let's say if a PID task is taking longer than 1 millisecond, it'll interrupt that task and go to the encoder task to do it again. The reason why we're using a task for this is because the Arduino Uno only has 2 interrupt pins, and each encoder needs 2 pins. So we'd only be able to have hardware interrupts on 1 encoder at a time. So we're just using software interrupts, so we have to check it really often. And it's really important that we check it, so we're interrupting other routines to make sure this gets checked. So for the encoder task, we're just going to the bot do interrupts routine. And if we go there, this just goes to the motor structs, and the motor structs I think aren't actually structs, they're classes now, but yeah, these just have a, let's see, do interrupts. Oh, this is oh wow, okay, never mind. It just directly calls like the encoder library read function and then updates the encoder. Right. So we fixed that. So the reckoning task. So every 5 milliseconds, it'll think about how many ticks for the left and right encoders happened since the last time it recalculated the dead reckoning, and it does some math with stuff, and then it updates the x, y, and angle coordinates. And then it just does something to limit the angle within like a reasonable range. The PID task, so this one, we set the angle hold and then we calculate angle factor. So angle factor is just sort of a value that we use here that's like positive or negative. So you can see here the target velocity we actually assign to the wheels is the speed target, which is positive, but for the angle factor it is negative for the left and positive for the right, which causes it to turn. So the higher the angle factor, the faster it'll turn. And then we actually just assign the motors to do this, so we're just going to bot.l motor to that run PID. So if we go there, you can see that we actually set the target because I think, I don't know if that's needed. And then we run the velocity control. So this is also set up to be able to do position control. I found it was more useful to use velocity control for the wheel PID. There is some weird overflow issues I was getting, so we're clipping it to positive negative 255. And then for the motor speed, I have motor speed positive and negative, but there's separate pins for forwards and backwards. So this just sees if it's positive or negative to use the correct pins to actually have it go in the right direction. So then in our bot state task, this is the least developed sort of thing. It needs a lot of work to work better, but I'll attempt to explain it. It's very jank. So we have a bot state variable that starts out at 0. So we set the target speed to 0, and then we calculate from our initial 0, 0 coordinate the angle that we need to face to drive towards the first target coordinate. You can see that we're using the coordinates lists, or matrix. I'm not really sure what it's called in this language, but yeah, and then we're using the chord count variable, which is currently set to 0. So this is my attempt to fix the angle. I need to write a much more rigorous function to calculate this angle correctly because this doesn't work, because sometimes when it only needs to turn, let's say like 10 degrees, it'll turn almost 360 degrees the other way because it thinks that's, I don't know, it's stupid. So we're logging the target angle, so I can sort of debug that. Then we go to bot state 1. So you'll notice that bot state 0 only runs for one iteration and immediately goes to bot state 1. So then in bot state 1, we're just waiting because we've set the angle target. So in our PID task, angle factor will have a value that's larger than 0, which will cause it to turn. And we're just going to wait until the angle that's calculated by the dead reckoner is within the angle tolerance, and we just do like an absolute value and less than here. So once that target angle is reached, we set the speed target to 15, so it'll start to drive forward, and we set the bot state to 2. So in bot state 2, not sure why this is here. I don't know, I'll have to fix this, but this tells it to face the target coordinates again for some reason. Then we wait for it to be within like so it's driving forward, so we wait for it to be within like a certain tolerance of the target position it's going to. Something to note is that this one's not very rigorous because if it, for example, drives to the side of where it needs to go, it misses its target, it'll continue to drive indefinitely. So I need to make this figure out how to compensate if it goes past its target or misses it somehow. But anyway, regardless, if it gets within this range tolerance, then it increments the coordinate count. So everything that refers to the coordinates refers to the next element in the list here. Let's see, where am I? We tell the console that we're done moving. We set the speed target to 0, so we stop driving forward. If we're at the last coordinate, which is 3, I don't really know if there's a way to check the length of an array in Arduino Uno, so I just have it be 3, but that will break if I add more coordinates to this. Yeah, so if it's the last coordinate, we just set the bot state to 100. There's no bot state 100, so it'll just do nothing for forever after that. Otherwise, it'll go back to bot state 0, and back in bot state 0, we're going to turn to face the next target coordinate. So the result of this is that it will turn to face, well, it starts at 0, 0, so it turns to face this coordinate, then it drives until it's within a tolerance of this target coordinate, and then it turns to face this coordinate, and so on and so forth. So the idea with this is that I would just measure the course, like what the target coordinates to go to navigate through the course, and this is just in millimeters. Then if we actually go to our setup function, we haven't even gotten to setup now, I need to move this into bot. I should have done that a long time ago. We're initializing the line followers. Actually, that goes right here. It should be. Anyway, so we're initializing serial. The PID things are kind of buggy and want you to like run the setup a million times for it to actually want to work. And then the runner.startNow. This is the most important thing. Runner is the task scheduler. So start now means it's going to start all these tasks. And then in the void loop, all that's in here is the runner.execute, which just says run the task scheduler. And that's how the code for this works.